Hi everyone, it's Stephen Downs here again. Welcome back to Ethics Analytics and the Duty of Care. We have another presentation on the go here, and I'm just going to get the URL. There we go, copy video URL, and put that into the system so that you can view it, although not only am I 2 hours late with this one, I'm 13 minutes late for my 2 hour late. So, not having the best of days, but not having the worst of days either. So, it's one of these things. So, let me just get this in here. Course Activity Center video. Just put that in here. And widen that out so I can put that in. We're almost there. It's kind of hard, and I will say this, to be the person who is writing the software for the course and the person who's providing technical support for the course and the person who's doing the learning design for the course, and the person who's delivering the course. Now, it's a lot. The presentation I'm going to give you... Oh, did I do something weird with OBS? Did something go wrong here? No, it's saying reconnection successful, so I guess... Alright. As far as I can tell, we're still running. I had a bunch of warnings pop up expressing concern about the state of my OBS connection. I'm using OBS to broadcast these, of course. So, alright, so let's go first of all back to the assignment, which we were looking at. So here we are with the assignment. Now, I've been filling it up with applications, and I've created this page. This is the page I tried to create yesterday and had all kinds of issues with, but I'll show you that page now. It actually does work. I just have to get to it. Here we go. Okay. Newsletter. Issue. Now it'll actually be the issue from the day before. Oh, right. Okay. Oh no, that's the yeah. Oh yeah, here's the page that I wanted to show you. So I had all kinds of trouble making this page, and it turned out that the problem was in the actual page template that I created, and I did stupid things and anyhow messed up the display. So here's the page. This is a test application, which I'll remove, but this is the list of descriptive analytics, and eventually we get a list of all of the different applications. Did I make that page? I'm not sure if I made that page. Anyhow, they're all gonna come together. We'll have all the list of applications. You'll be able to page through it just like anything else. So I've been working on that. Now, your assignment, of course, was to go to one of these two forms, either add an application or add a link. So if you add an application, the idea here was to think of an application that I haven't covered yet, put in a title, put in a description for it, and then submit. And so I'll give you an example of me submitting one. So here's one, academic advising, and so I'm going to submit it. Where'd it go? Here we go. Oops. So here we are. So academic advising, so I'm going to submit academic advising. I'll give it some text as description. I'm getting this from stuff that I've already written in the past. So here we go, academic advice. So it's easier for me just to do that. Although, you know, I mean, this is a nice way of giving me a chance to be able to rethink it. Now, academic advising is a type of predictive analytics, and we hit submit. Now, you don't have to add a module, and in fact, I'll take that off. But if you did add a module, you would update it. Ignore that little pop-up, that's diagnostic, and you'd see it goes into the module. You're not going to see this. These won't work for you. I'm just working now on figuring out how to remove them. But excuse me for the sneeze. I'm also coughing and sneezing during my online work today. Anyhow, so that's the first of these. Now the second of these is, I think, potentially a lot more interesting. So the second of these is the add a link page. So here's the add a link page. So let's find a link. So here's something, student monetization. What was this? This was, oh yeah, all right. I don't like that one. Student monetization isn't really an application of learning analytics, no matter what it says. Although, you know, I guess, you know, dropout and store prediction. What did I call this? Student outcome prediction or something? Well, I don't know. But it's a link that's relevant. So, and I don't know, but let's put the link URL in here. And let's put the title in here. So, where did it go? Here we go. 5 applications of learning analytics. So, keep losing my place here. So, I'll put that in there. And now maybe a short description. So, let's just pick one. So, analysis of the factors that student outlier detection. These could all be independent ones, couldn't they? I might add some of these. So, right. So learning analytics is here we go. I'll just take this. Again, it's probably better to actually type some text rather than just cut and paste. But I'm super lazy. Okay, and I'll put it in quotation marks to indicate that I have in fact quoted this. And now I'll submit. And now, okay, so we've submitted our link, and it'll show up in the list of links. What application is it? So here are the applications. Again, I'd love this to show better, but we can still look at this and ask ourselves, well, what kind of application is this? And identify students at risk of failing certainly is exactly what it says there. So I'm going to click on that. I'll update. And okay, so here we have this identify students at risk of failing. So this is useful because what's going to happen now is if we come back to our analytics page, okay, now it's on a different page, but we will actually show the links with the short description under each one of these. And we're creating a graph, aren't we? We have the application of the analytics. Now we have a link which ties to a specific application of analytics. So it's just one link in our graph, but that's how you build graphs, right? One link at a time. Now you can use an artificial intelligence system to do some kind of content analysis and draw the links that way, but we are the ones doing the learning in this course, so we are the ones creating the links. So there you go. So that's the objective. That's the whole point of the task, is to do that. And if you do that and you want to be recognized with a badge for that, write it up in your blog. You know, you don't need to do a whole number of links. All you need to do is one, and you qualify for the badge. So, and you don't need to do any, you don't need to add any new applications of analytics. It's pretty tough to find new applications of analytics. If you do, great. But really, the main thing I'm looking for here is the link. So find the link, write it up in your blog, and that'll come in the RSS feed, and you'll be awarded with a badge. I'll be showing how I award the badges and the list of badges awarded a little bit later in the course, but trust me, I keep records of all. No, that's not true. I don't keep records of all, but I have all the links that I've harvested. Really, that's all I need in order to start awarding badges. All right, so that's that. Now what I want to move to is the presentation for today. And the presentation for today is Diagnostic Analytics. So let's start this puppy up. Don't be so. Oh, it's going to give me the full screen. Okay, so the way you avoid that, in case you've ever wondered, set up slideshow, browse by individual. Okay, now when I start, I'm not occupying a full screen, and I can do things like size it and all of that. And then I can move it around my screen, and you don't even notice that I'm doing that. All right, so Diagnostic Analytics. So as we mentioned, was it all the way back on Monday, or yeah, it must have been Monday or Tuesday, Diagnostic Analytics look more deeply into data in order to predict patterns and trends. And we looked at some of the ways that analytics will do that, for example, classification or categorization, some of the other operations. So that's what Diagnostic Analytics does. Now, what I want to offer in this particular presentation is a discussion, really a listing of some of the different types of diagnostic analytics that are being performed. So these are all based on actual examples. We're not making them up as, gee, maybe they could. No, there's actual work being done in each of these areas, and in fact, each one of these areas could be a whole course on its own. For our purposes, we're not going to go deeply into any of them because we can't. But it's important to know that the application exists. It's part of the use of analysis and artificial intelligence in learning, and therefore it is something that has the potential to raise ethical issues in the future. So on the one hand, we're saying what the benefit of this application is, but we're also taking note of it so that we can come back later and look at it from the perspective, does it create an ethical issue? So here we go with the list of diagnostic analytics. So one of the ones that I've used a lot and is being more and more used by people is audio and video transcription. There are many such systems available now. These are 4 that I've used just in the last week. Google Recorder, which I should have turned on now even. There we go. So I've turned on Google Recorder, and as you can see, Google Recorder is providing a live transcription of this talk as I give this talk, which is really handy for me. And the quality of Google Recorder is pretty good. In some cases, I forget to use Google Recorder and get the live transcription, so I take the audio file and I upload it into Microsoft Word or Office 235, Office 365. That's pretty funny. It doesn't work on the desktop version, only on the cloud version. Another audio transcription tool is Otter.ai, which is a commercial tool. It's very good, but I've used up all of my free sessions on it. And even Zoom, and I've been playing around with this, Zoom will produce transcriptions of the Zoom conversation that are visible on the screen as we have the Zoom conference. Very much an application of analytics that's in wide use today. Security is another wide area for diagnostic analytics. There are different types of security, different ways you can use AI to support security. You can do everything from risk assessment to threat detection, anomaly detection, and more. Some examples: there's the Aegis facial recognition software, which is being used in schools for school safety. And of course, facial recognition raises a whole set of issues, which we'll be talking about later. Or from the standpoint of your computer system, an application like Citrix will monitor incoming digital traffic to detect and deflect potential threats such as hackers, viruses, even spam, although that's a separate category. Access control is another application of diagnostic analytics, similar to security, but here it's focused on a specific gate kind of mechanism. Do you allow access or not? That's different from flagging things that might be dangerous. Here you're specifically giving them access. So one type of access control is building access. We can think of all the different ways we can use analytics to determine whether somebody should be able to access a building or not, or for that matter, a country or not, right? Sign-in authentication. People often present fake credentials, and Threat Matrix is an analytics engine that determines whether the presentation of credentials should be taken as a genuine presentation of credentials or a fake or fraudulent presentation of credentials. If you think about that, think about, for example, your credit card. If you use your credit card to pay for something, that's a presentation of credentials. But what might happen is somebody steals your credit card and then tries to buy a sailboat. Now, that's an authentic presentation of credentials, but it's fraudulent. And the fact that it's a sailboat, the fact that it's $30,000, the fact that it's a transaction being conducted in Greece, all of these things and other factors may combine to suggest that to an artificial intelligence agent that this particular transaction is fraudulent, and it'll be flagged. In my case, I actually got a phone call from the credit agency on my phone saying, did you really do this transaction? Of course, if they have my phone, they may say yes, but you can add security to that. Similarly, with access to contents, if you look at access patterns, an artificial intelligence can determine whether somebody's illicitly accessing protected content. A well-known example, not one we were happy to talk about, was when Aaron Swartz tried to download all of JSTOR's collection of research papers. That activity was flagged as potentially illicit, and it was stopped, and then he was charged, and then bad things happened. It's a use in analytics to monitor and control access. Again, though, it raises ethical issues. Another type of diagnostic analytics is spam detection. And spam detection's in wide use on the internet, and the tools are getting more and more sophisticated. Back in the beginning, they used things like Bayesian filters or analytics based on the principles of probability, but now machine learning is being used to filter spam. Can be done either yourself on your own computer desktop, or more commonly a commercial system like Axonet is used These are very powerful systems that are really good now at picking out spam messages from your email. If you look at say your Google Mail inbox, it picks out the spam and throws it in a separate directory. And you look at that directory, especially after it's been running for a while, and there are very few false positives, that is to say, identifications of mail that is not actually spam but flagged as spam. And there are very few false negatives either. There's very few cases of spam that actually get through to your real email inbox. Plagiarism detection is another use. It's slightly more controversial. It used to be you just matched the text, right? The student handed in some text. You check to see if you could find that text string anywhere in the internet. Students are smarter than that. They change the text a bit. They try to obscure the origin of it by paraphrasing, etc. So artificial intelligence systems are used to identify cases where it's similar but not the same, and there are different mechanisms that can be used, maybe substrings, maybe fingerprinting, maybe bags of words, maybe even the style in which something is written. And as well, artificial intelligence will look at previous student work and current student work to see if they're the same. So, it's getting harder and harder to plagiarize because analytics engines are getting better and better at detecting plagiarized material. But again, questions come up about the ethics of this. Similarly, with proctoring, there have been a lot of questions about proctoring. Should people be subjected to AI analysis at all when they're doing their tests? What kind would be appropriate? Proctoring systems can look at their keystrokes on the computer, the way they type, comparing the way they've typed before to the way they type now. Proctorio uses artificial intelligence to look at people through a camera and determine where they're looking. That's why Proctorio says, no, we're not using face recognition. And that's true, right? They're not comparing the person's face to a database of faces, but they're looking at the face that is on the camera, the person taking the test, and checking to see what they're looking at. So they can determine whether they're looking away, looking at their notes, whatever. That's the theory anyways. Again, there have been many disputes and many ethical issues raised by proctoring. Fakes detection is something I think we all want, right? The idea of fakes detection is to look at a photograph, and now these days a video, deep fakes video, and try to determine whether it's an authentic photograph or video or whether it's been manipulated in some way. Again, these are difficult to determine, and the cues that suggest that something is a fake are beyond what the individual person like you or I can identify as a clue that something is fake. However, there are biological signals, there are signal transformations, feature vectors, etc., that can be analyzed on a pixel by pixel basis by an AI engine, and this allows it to run through things like feature extraction or authenticity classifiers and make the determination whether something is real or fake. Now, again, more issues, and we'll talk about these issues in the next module, but the whole idea of running photographs, publicly accessible photographs, through a pixel by pixel analysis might raise some ethical issues for people. Another case is using artificial intelligence in analytics to identify and support special needs, particularly in the case of students who are special needs. For example, and that's what we have here, is a student with dyslexia might have more difficulty reading, especially reading printed text that's on a screen. How do you detect this? The student themselves might not know that they have dyslexia, but you want to be able to support this. So this artificial intelligence in particular analyzes a person's eye movements. So they're looking at where they're looking on the screen, how long they linger at a place on a screen, and a person who has dyslexia will have a different pattern of eye movements than a person who does not. And thus, the system can flag a person as dyslexic and then recommend or even implement some adaptation in the system to better support that person, perhaps using, for example, a dyslexic friendly font, or even trying out different fonts, different font sizes until it finds something that matches. There are also ways of detecting autistic learners through the use of computerized glasses, and so on. For every special need, there's a way of detecting that special need. Although the question is, should your educator be doing medical diagnosis on you? And other ethical issues may come up as well. Sentiment analysis is similar. These are widespread. Affectiva, Beyond Verbal, and Sensei, all offering products that do plug-and-play sentiment analysis. The idea is that in clickstream data, interaction patterns, bodily signals, the things you actually write, and more, an artificial intelligence system can classify what sentiment you're expressing, whether you're angry, happy, sad, disappointed, fearful, whatever, even if you're not saying that you are any of these things. And of course, once it's detected this, it can then perform whatever action it or you deem is appropriate. This can also be used for opinion sampling or opinion mining. Sure, we could give people a questionnaire, and that's the most common mechanism for opinion sampling, but people lie in questionnaires. It might be more accurate to identify what a person's opinions are on different subjects by looking at what they write about and how they write and what words they use and whatever generally. So an AI will look at unstructured data such as letters, phone calls, social media, videos, whatever, and analyze the content of these communications and then classify them according to the different types of options available in the opinion survey. So, if you're left wing, but you haven't actually represented yourself as left wing, an AI system could kind of determine that you are left wing by the way you talk, the things you talk about, the words that you use. This is sometimes known as dog whistling when you use words that are recognized by a particular community, and we might think of this kind of artificial intelligence as a dog whistling detector. One widely discussed and to some degree widely used system of analytics and AI in learning is automated grading. Automated grading, viewed from the perspective of analytics, is a categorization task. That's very different from the way we might think about grading from an instructional perspective, where we're looking at, did they do this kind of thing? Did they do that kind of thing? Did they cover this topic, that topic, the other topic? Automated grading doesn't look at it from that sort of perspective. It doesn't look at it from a semantical perspective. It doesn't look at the meanings of what's being said or comparing what's been written against a set of requirements. It's not, as is popularly supposed, looking for certain keywords or jargon. Rather, what it's doing is it's working from a body of already graded assignments. So it does need a training data set. And based on that body of already existing graded assignments, it takes a new essay and says, which one of these piles is this most similar to? So your body of previously graded assignments will already be classified into 5 sections, right? A, B, C, D, and F. So your new assignment is compared to the existing assignments, and then the AI says, well, it most resembles the category C, for example. And so it's taking into account, as I say, not the semantic elements, but it's taking into account elements of the data set that are not necessarily known even to the grader. The person grading the assignment might have a preference for a certain writing style, or might have a preference for a certain way of approaching the subject. There's a wide variety. We don't know necessarily what the AI is looking for, but that's just a fancy way of saying that while the person grading the test might be looking at a few hundred factors, the AI might be looking at a few million factors. And so it's going to be much more precise in its categorization, and research has shown that it's much more consistent in its categorization than human graders are, especially across different graders. Another way to use this sort of capacity is to do competencies assessment. Now here, we're not looking at written material like a test or an essay. We're looking at a person's performance as evidenced in a trail of data that they leave behind them when they work in a digital environment. It might be their behavior in eating, in activities. It might be the way they express the way they think, by the way they reason through problems. It might simply be by the way they fix something or solve a problem. There's a wide variety of ways that a person's competencies can be assessed, but once again, it's a classification problem. We look at experts who are already competent, and we look at people whose competence we don't know, and compare, and we can say, yes, they are an expert, no, they aren't an expert, or we can give them degrees of competence depending on how we've set that up. Now, once again, the neural network system, the machine learning, isn't looking necessarily for a set of previously defined indicators that such a person is competent, but maybe looking at multiple factors, including factors that are part of being an expert, but we don't recognize when we just look at an expert. Even perhaps the way they carry themselves, how confident they look when they approach a task. I'm just picking things out of the air here, but we can imagine that. And that's the list of diagnostic analytics that I have for now. And so with that, I'll draw a conclusion to this video. We've still got 4 more sets of types of analytics. They're not all as long as this set, but you can kind of get the idea of the sort of thinking that we're doing here. And again, it's not so much whether these applications of analytics belong in this category or another category. We could probably come up with other ways of categorizing them. Maybe we'll think about that a bit on Friday. The main thing here is that we're drawing up these many different examples of the way analytics is used in education, and as you can see, it's about a lot more than recommending some learning resource or predicting whether someone will fail. So that's it for this video. Thanks for watching, and I'll see you in the next one.